Hello, class. I saw this. There's a lot of interesting articles, actually, a lot of cool science going on right now, but this one caught my eye. There are several that caught my eye, but I'll save them for next week unless something more cool comes up. You never know with science. And this one's about element number 119. It's not been discovered yet. Right now, we know of 118 elements, and this is interesting. And this article here is full of politics because U.S. and Russia, we don't collaborate too much anymore scientifically because of the Ukraine conflict. And so we are in the United States, we're chasing element 120, and Japan's going after 119. Japan's got a harder job. So 120 is going to be an easier element to make if it does exist. We don't know if it exists because when it comes to nuclear stuff, the odd number of protons, those are less stable elements, and that's because of something called the pairing energy. Because protons and neutrons are fermions, just like electrons. They have spin up, spin down, and when they're paired together, that's a more stable configuration. So the even number of proton elements they're much more stable. Stable is in they are less radioactive. There are very few odd protons, odd neutrons, nuclei. There's usually an even number of neutrons and nuclei as well. Same reason, pairing energy. And so, arguably, there are 90-ish naturally occurring elements. So, it depends on whom you ask. Darlene Hoffman, for instance, found a little bit of plutonium in a rock. It's estimated there's tens of grams of natural plutonium on the Earth. We have a lot more because we've made them for nuclear weapons. And so you can see here, United States, we've discovered these elements, and you can see berkelium, californium, for instance. They were mostly found at Berkeley, California, where I went to grad school. That's where I got my PhD. So we're always very, very proud of those elements that we've discovered. And these elements, their primary uses, they're for nuclear weapons, especially plutonium and californium are used in nuclear weapon, and uranium, but our uranium, that's not necessarily discovered. Some of these elements, these were discovered by atomic weapons. So we blew up atomic weapons, and we've blown up a lot of atomic weapons. We've blown up over 2,050 nuclear weapons, about 500 of them in the atmosphere. And so we would look at the fallout dust, and we'd analyze it, and we found some new elements. But the way we do them now, we've no longer been testing nuclear weapons, at least not like as far as detonating them. But we make these super heavy elements by taking beams of elements, and then we cross them, and then if an occasion they meet and they can have nuclear fusion, the nuclei fuse together, and they make the elements. And it's a really hard process to do, actually, because so there's something called the barn size. So certain nuclei, they call it the barn. Xenon, for instance, has a huge barn. So it's just really easy for a xenon to engage in nuclear fusion reactions. And typically in these super heavy elements, the barn size gets smaller and smaller. The other thing is that when you form these elements, they have an excited nuclei, and they usually have to cool off. They cool off by giving off gamma rays, and they're not very stable. I mean, because they have all this positive charge, all that positive charge in the center of the nucleus, and all that positive charge is repelling. It wants to break apart, and that's the idea with the nucleus. You got all this positive charge in it, but you have the nuclear strong force that's keeping it together. And one of my guilty pleasures, I must say, is I watch a show sometimes called Ancient Aliens. That dude with the big afro hair that goes, and I just like the way they talk about things, and it's so ridiculous. And apparently in Ancient Aliens, Element 115, the alien technology is based off Element 115. We've discovered it, but honestly, it's not very useful. So and none of these are useful. In the article at the end, it talks a little about technetium. Technetium is right here. This is the first man-made element. And they said it has a half-life of 6 hours. That's kind of true. The metastable state, it's an excited nucleus. Technetium has a much longer half-life, but the excited nucleus, it's formed from molybdenum, and then from beta decay to form technetium. And when that happens, it's radioactive. And I've had some nuclear medicine using technetium. For instance, I had a stomach emptying study. They wanted to see how long food was kept in my stomach, and I had to eat a radioactive sandwich that had technetium in it, and it didn't taste very good. In case you're wondering, I was a little relieved, right? Like, well, what if I just love radioactivity? And yeah, it was all right, but I wouldn't say it's a specialty. But yeah, it's interesting seeing that. But we do use technetium. This is the first man-made element, of course. There's also promethium right here. This is also man-made, but that's where you can get 90. If you're wondering why there's 90 elements, why is there more? Because some people do include technetium and promethium, and maybe you include neptunium and plutonium as well. I mean, you never know. And there are other things. So also look at this as partially national pride, right? I mean, trying to see it. Oh, and they talk about the island of stability. This is so there are magic numbers. So like electrons, when electrons have the same number of electrons as a noble gas, they're just particularly stable configurations. Same thing with nuclear. There's a particularly stable, and they're hypothesizing that there is this island of stability in the super heavy elements, so that we might be able to find elements that are super heavy that are more stable. So maybe exists. I don't know. This is one of the things that we're chasing and looking for. So it's interesting. This is a fun article. I know I'm giving you a little bit more background. I started out doing this stuff in grad school, and I changed to chemistry. So I'm a big fan of the nuclear stuff. But it's an interesting article, and I hope we find element 119 and 120, and then we'll have to get new periodic tables, or take the old ones and put some post-it notes on it or something like that. So that'd be kind of cool. So, anyways. With all my messages, I hope it finds you extremely well. And if you're not doing well, if you have a lack of basic needs, if you're dealing with some mental health issues, or if you have any other issues, please let me know. I will do what I can to help out. And I hope you enjoyed the article. So I will sign off then and say aloha.